Okay, so good morning to all. So let's start today's session. So in last lecture, what we learned, we again solve one of the example of the alternator. Yes. So today we start the new topic which is known as the armature reaction. So till now, what we learned the basic idea about the alternator, its working principle, then its EMF equation, and generally what we are doing, alternator is nothing but it is the synchronous generator. So the name of the alternator is synchronous generator. So it is rotated at the synchronous speed only. So again, what we are doing, we are giving the DC supply to the field. Okay, to generate the field, we are giving the DC supply to the alternator. But again, there are two parts of the alternator. One is the armature and another one is the field. You can see. Okay. So we have two options. Either we are rotating our field and armature making a stationary, or another option is we are rotating our armature and our field will be stationary. In DC generator, what we are doing? There are two options. Either we are rotating the armature or conductor, and my field will be stationary. And another option is either I am rotating my field and my armature remains stationary. So in DC generator, what we are doing? My question is, in DC generator, what we are doing? Either we are rotating our armature or we are rotating our field. You are aware about the DC generator? We are rotating our armature. Yes, we are rotating our armature. So in DC generator, my field winding is remain stationary. But here in alternator, we are doing the opposite thing. In alternator, we are putting our field winding onto the rotor. Actually, rotor is the rotating part. So here in this part, my rotor is rotating, or you can say my field is rotating, while as my armature is stationary. Okay, there are numbers of advantages of that. That's why we are using that. So that we also see. So in armature, there are different types of winding we can make. So we have three possibilities. Okay. So either we are, what we are doing, either we are using single layer or a double layer. Suppose you are selecting a single layer, then there is a single layer alternator. Then another option is either you are winding your concentrated or distributed all over the alternator. So again, you have to select either you have to make your winding concentrated or the distributed. Third option, either it will be a full pitch or it will be a short pitch. So again, that you have to select. But generally, what we are doing, our armature is either it will be a single layer or double layer. That's it's based on the load or based on the capacity of the alternator. But most of the time, instead of distributed or concentrated, we are selecting the distributed winding only. And on the selection of the short pitch and full pitch, we are mostly select the short pitch only. So my winding, armature winding is single layer distributed short pitch or double layer distributed short pitch. And while you are distribute your winding, then there is a distribution factor which is denoted by KD. And while you are short pitch your winding, there is a pitch short pitch factor. You can say it is KP or KC, pitch factor. So up to that, and we already learned about the EMF equation. Okay, because it is a generator, you are not giving any supply, it will generate its supply by own. So what kind of voltage or what is the amount or what is the magnitude? Okay, voltage generate कर रहा है तो कितना कर रहा है? 200, 400, 600. We are not aware about that. So for that, what we are doing, we are deriving the equation for the EMF, generated EMF, same as we have the equation of the generated EMF in the DC generator. Okay, so when it is a generator, there is always a equation of the generated EMF. So up to this, what we have learned, that is I'm giving. Now today we have to start the new topic, which is about the armature reaction. It's not new for you. Okay, so the MU students are already learned this thing in a DC generator in a third sem, and you guys are already the students from the GTU. They already learned this thing in the fourth sem only, because you have the subject DC machine and transformer in the fourth sem, while as the MU having the same subject in the third sem. Okay, so armature reaction is the not a new thing, but what we learn of this thing in the DC, and DC is very much good. Why? If you are not getting shock, then DC is very good. But when you are getting the shock, then DC is very bad, because there is a no chances of survival when you are getting the shock and that supply is DC supply, because in DC there is no zero. While in AC, in a single cycle, you have three possibilities, because at that three times in single cycle, the voltage or current will be zero. Okay. But why DC is good? Because there is, when we have a DC, we do not have the effect of inductance and capacitance. Okay, and in DC we are not talking about the power factor. If you are learn about the equation of the power, so in DC the equation of power is P is equal to only VI. While it is AC, then the equation of power it is VI cos phi, and that cos phi is the power factor. Okay, so in DC generally the power factor is always unity, so we do not have to more think about the inductive reactance and the capacitive reactance, or you can say the effect of the inductance and the capacitance on the alternator. Okay, but when it is AC, we have to see about the power factor. Okay, so when you are generating the power, so power factor is depends on what thing. Okay, you have a generator. It generates 400 volt or some amount of current. Generally, the capacity of generator is it's in the range of same way MVA, KVA. It is not like a motor, kilowatt, megawatt like that. Okay, and that you already learned why the transformer rating is not in watt and it's in the VA. Same, it is applicable for the alternator and generator also. So my power factor is depends on what thing. Suppose you have a generator. Okay. So either it will generate the unity power factor, AC generator I am talking. Okay. Either it will generate the unity power factor, or it will be generate the leading power factor, or it will be generate the lagging power factor. How you are defined that? How we can aware about that? My power factor is either unity or the leading or the lagging. It is basically depend on the load which you are connecting with the alternator. Suppose you are connecting a purely resistive load. Alternator doesn't aware about that either my power factor is unity or lagging or leading. What does the current load? Your load flows the current from the alternator. So suppose your load is purely in resistive nature, then by default your alternator generates the unity power factor. Suppose instead of resistive, you are connecting your lights and fans. So fan are the inductive load. Our induction motor. You are learned about the induction machine. So our induction motor is the inductive in nature. Okay. So if you are connecting this type of load, then it will be a purely inductive. Then it will be taking the lagging power factor. And suppose your load is like that, it having a more capacitive in nature, then your power factor is leading in nature. So here, when we are talking about the armature reaction, we have to also aware about that either my load is resistive, either my load is inductive, or either my load is capacitive. Or it is the combination. Actually, we have the combination of RLC load. Suppose we are talking about the this single phase. This is the motor actually. In fan, there is a motor. And it is a single phase induction motor, but you are aware about that there is inside, there is one capacitor. There is one capacitor. If you remove the capacitor, your fan will not start. Okay. As I know, you are not learn till now you are not aware about the single phase induction motor, but this is the single phase induction motor. So your three phase induction motor is self-started. While you are giving the three phase supply, it will rotate by itself. But your single phase induction motor is not self-started. So we have to make it self-start by putting a capacitor. Okay, that you will learn more in a unit number 2 about the single phase induction motor. So But generally in that load, we have the inductive nature also and capacitive also. And there is winding, there is some resistance also. So we have the load generally combination of RL and C. But what is dominant on that? According to that, power factor is vary. Okay. If our load is more capacitive, then it will be leading. If our load is more inductive, then it will be lagging. And my capacitive and inductive load are balanced each other, then it will be resistive in nature. Okay, so that we will learn by in today's session. Okay. So up to this, if anyone having any doubt, you can ask me a question. Anyone, those who are study this lecture from the online also. So if anyone having any doubt, you can ask me a question on chat. Okay. So now again, so first one is what is the armature reaction? Okay. And why its name is armature reaction? Because it's created due to the armature flux. Okay, when it is created by the field flux, then its name will be the field reaction. But field is used for the generating magnetic flux only. Okay, the working of the armature is not creating the flux, but due to the magnetic principle, when any current is passing through the conductor, so we are aware about that. If the current is passing through the conductor, surrounding the conductor, a magnetic flux is created. And that flux is either oppose the main flux, or it will be help to the main flux, or it will be distort the main flux. So we have three possibilities, and that is known as the armature reaction. Okay, so let's see. When suppose my alternator, okay, alternator is nothing but it is the AC generator. Remember that thing, alternator is a device which generates the AC power, like our DC generator. So when my alternator is running at no load, so we are not connecting any load with the alternator. Okay, like this. Suppose this is a 3-pin socket. I am switched on this, but I am not connecting any load here. So no current will passing through this. And as there is no current is passing through the alternator, no flux is created on the alternator conductor. Okay. So it will be same like our 3-pin socket. Okay. So there will be no current flowing through the armature winding. And the flux produced in the air gap will be only due to the rotor ampere turns. Rotor ampere turns means due to the field winding, because we are putting our field winding onto the rotor and we are giving the DC supply, and that's why it is known as the ampere turns. Okay, you are aware about the MMF. What is MMF? The full form, magnetomotive force, and its unit is, you are aware about the equation of MMF. What is the equation of MMF? MMF is equal to, this equation is MMF is equal to N into I. Okay, when N is the number of conductors and I is the current flowing through that conductors, and the unit of the MMF is ampere turn. Okay, that's why here it is written as ampere turns. That's the unit of MMF. So because the MMF is the thing which generates the magnetic flux, like EMF generates the current. Okay, so MMF generates the magnetic flux. MMF શું કરશે? Flux create કરશે. અને કેટલો flux create કરશે? જેટલા નંબર ઓફ કંડક્ટર્સ અને જેટલો એમાંથી કરંટ ફ્લો થાય એટલો. એટલે એનો યુનિટ છે, એનો actual equation છે MMF is equal to N into I. But here N is not the speed, N is the number of turn in the armature. Okay, number of turn, and I is the current flowing through that conductors. So that's why its unit of the MMF is ampere turn. It is denoted by AT. A for ampere, T for turn. Okay, and that's why it is written here rotor ampere turn. So it is nothing but field winding which generate the magnetic flux. So when we are not loading our armature, so only we have only one flux which is generated by the field winding, and that field winding we are putting on the rotor, and that's why it is known as the rotor ampere turn. But suppose I am connecting the load with my alternator, then So when the alternator is loaded, we are only here talking about the three phase only. Okay. So when my sorry. So when my alternator is loaded, the three phase current will produce the totaling magnetic field. Why now totaling magnetic field? Because now I am loading my alternator. So there are two flux are there. One is generated by the field winding and another now generated by the armature winding. So there is a totaling flux. Okay. In the air gap. So consequently, due to that, the air gap flux is changed from no load condition. Okay, when we are not connecting the any load, then the flux will be different. But while you are connecting your load, then my flux is different. Okay, so this is the definition actually you can say. Suppose you have a one line question or only a single mark question, one mark question, define armature reaction. So the main statement is that the armature reaction is nothing but it is the effect of armature flux on the flux produced by the field ampere turns, or you can say it is the effect of the armature flux on the main flux. Both are same. Is called the armature reaction. Is called the armature reaction because suppose your exam will be offline, then there is a question 1 of the 6 marks and there is a 1 mark questions. Okay, there is a 1 mark question. So this will be asked in the 1 mark. Okay. So here you can say what we have to learn. We have to focus on the load. So two things are worth noting about the armature reaction in the alternator. What are that? So first one is the armature flux and the flux produced by the field winding. Here I am not talking about the rotor ampere turn, it is only a field winding. Rotate at the same speed. Remember this thing. Okay, this is only possible in the alternator because it is a synchronous machine. In your portion, there is again a topic which is known as the induction generator. So induction generator is not an alternator. Okay, the both the machine are similar, induction machine and synchronous machine, but the main difference is that induction machine will never rotate at the synchronous speed, and synchronous machine is always rotated at the synchronous speed. That's the main difference between these two. Okay. So my armature flux and the flux which is produced by the field winding both are rotating at the same speed, and that speed is my synchronous speed. Okay, and is in the same direction also. And therefore the two fluxes are fixed in the space relative to each other. Now second one is that the modification of the flux in the air gap. I'm again today I'm forgetting the pen actually. Suppose this is the air gap. Okay, as I already told you, this is my armature and this is my rotor. It will never touch to each other, otherwise it will not rotate. There is some air gap, which air gap is in the range of millimeters only. It will be not like centimeters like that. Okay, it will be on only the millimeters, and that gap is known as the air gap. And our flux is always rotating, is there from the air gap flux. You have the subject machine design also. So on that, from the I think in the next semester. So on that you have to learn about that how you have to design the flux. Then you have to select which amount of gap you required, either 10 mm, 12 mm, and what's the effect if you are increasing the gap or you are decreasing the gap. That will be in the next semester. Okay. So just you have to aware about that. What's the air gap? Okay. So the air gap flux depends on the magnitude of the stator current. Stator is nothing but our armature. So magnitude of the armature current, either it will be a 10 ampere or a 100 ampere or the 1000 ampere. And secondly, main important is it depends on the power factor of the load. Power factor of the load. Okay, so this is about the armature reaction. Now we have three cases of the armature reaction. Okay, because I have three types of load. I already told you about that. I have either purely resistive load with power factor is unity. So the first case, when my load power factor is unity. I have inductive load in nature, then it is the second case when my load power factor is zero level. I have capacitive load in terms of nature, then the third case is when my load power factor is zero leading. So we have to learn about the three cases. Either my power factor is unity, or it will be a lagging, or it will be a leading. So it is the load power factor which determines whether the armature flux distort. So it will distort the main flux. Distort means suppose it is in sine wave in nature, but due to armature flux it will be not sine wave. It will be distort like that. So either my armature flux is distort the main flux, or it will be oppose the main flux. Suppose my armature flux is like that, then my rotor flux is in opposite nature. Suppose my armature flux is sine, sorry, my main flux is sine in nature, my armature flux is cosine in nature, and when you are taking the average, it will be sometimes zero also. So it will oppose the main flux, and sometimes it will be help. Suppose my armature flux is sine in nature, my main flux also in sine in nature. So total flux is adding. Total flux is adding. So we have three possibilities. Either that armature flux distort my main flux, or it will be oppose my main flux, or it will be help my main flux. Okay. So up to this, anyone having any doubt? Anyone having any doubt? And those who are attending the sessions from the online, I request them online from the hostels. So I request them please come to the classes. Okay, those who are outstation, they can attend the session from online, but those who are sitting on the hostel only or staying in the hostel only, most of the MU students are from the hostels. So I request them please regularly come into the classes. Okay, and attend the sessions physically. So now let's see the each cases one by one. Okay. So my first case is when my power factor is unity, and when it is possible, we are aware about that when my load is purely in resistive nature. So you can see we have two figures, figure number 1 and figure number 2. And here we have three phase winding. So three phase we are aware about that it is RYB. So here this is my R phase R1 R2. This is my Y phase Y1 Y2. And this is my B phase B1 B2. Okay, and it is 120-degree physically. Okay, it is displaced 120-degree physically, because you can see after R1 my Y1 is, after R1 my Y1 is 120 degrees distance, and after Y1 my B1 is 120. Okay, here I am not writing B2 because it is R1 Y1 B1. It is 120-degree in that. Okay, like that. Those who are online, let me show you. It is like that, 120-degree physically separated. Okay, electrically. And then you can oppose the winding, because when my R1 is around on the end pole, then exact 180-degree my R2 is there. Then my Y1 up to Y1 exact 180-degree my Y2, and from B1 exact 120-degree there is my B2. Okay, it's like that. So now you can see here Figure shows an elementary alternator at no load. So I'm not connecting any load here. So in case one, alternator is at no load. We are not connecting any load, either resistive, inductive or capacitive. So it is at the no load. So my flux is equally distributed. You can see here. And in case number 2, I am connecting the load purely resistive. And then you can see the flux. It will be 90-degree more. Okay, so let's see it. So in case number 1 or figure number 1, simply we are not connecting any load. So as we are not connecting any load, so no current is passing through the armature conductors. So my armature is open circuit like that, this socket. So there is no current, and flux due to rotor current is distributed symmetrically in the air gap. So only one flux is there. It is because of the field winding, and it is symmetrically distributed all over the world. So since the direction of the rotor is assumed clockwise, okay, here my rotor is rotating. Okay, remember that thing. Here my rotor is rotating, and we are assume that my rotor is rotating in the clockwise in direction. Okay, clockwise in the direction. Like see here, it will show the arrow also. It gives the direction of rotation. This arrow. So the generated EMF is phase R1 and R2 is at maximum. Okay. Because first of all, here it is the N pole is exactly at the R1 and S pole is exactly on the same at the R2. And when it will rotate, it comes to the B1 and B2. Then my B1 and B2 at the maximum. Then Y1 and Y2, then it will be at maximum value. And due to that, my three-phase EMF is generated. You are aware about the three-phase voltages. Okay. So when we are talking about the three-phase, so we always start with the R phase. So this is my R phase actually. Okay. After 120 degree, like this is 90. So here, something here. Okay, I do not have a pen properly, but actually here, now my Y phase is starting. And it's like that. And exact after 120 degree, so actually 240 degree from the R phase, or 120 degree you can say here. So after the exact 120 degree, my B phase is starting. Why it is so? Because of the rotating of this. First of all, it will be at the mainly at the R phase. So my R phase is starting. Then it will be, you can say here it will be after before the Y1, it will be come up across the B, but it is not come across the B. B1 is actually here. So it will be B2. So it is opposite. Then it will become to the Y1. Okay. So when we are not connecting any load, this is our generated EMF. Suppose I am extending this. So this is actually my B. And this is actually my Y, like that. Okay, so this is a three-phase generator, voltage generated when my alternator not connected with any load. Okay, but when you are connecting a load, this waveform will be distorted according to your load. Okay, voltage remains same, but the current will be changed. Suppose if you have any lab which you are learned in the computer lab, and if you are using the MATLAB, so simply try this one. Give the three-phase supply to purely resistive, check the voltage and current, then give to the inductive, check voltage and current, and then give to the capacitive load and check voltage and current. then you can easily aware about that what kind of difference are there. Okay. So here, so the generated EMF in phase R1 and R2 is at maximum, and it is toward the paper. Like suppose this is my paper. So in the conductor R1 and outward to the conductor of R2. So current you can say it is inward to the R1 and outward to the R2. Here what you have to do, you have to aware about the right hand rule. Okay, you are aware about the right hand rule. What's the right hand rule? We have to put our first finger, middle finger and thumb at the 90 degree to each other. Then what my first finger indicates, what my thumb indicates, and what my middle finger indicates. Thumb indicates force. So it is the direction of alternator, you can say. First finger, it is the direction of magnetic field, and that my thumb indicates the direction of current. Either it will be inward, or suppose my conductor is going to the downward, then it will be a outward. So here, that's why it is inward, and then it will be outward like that. Okay. So no armature flux is produced. Why? Because my armature is at no load condition. So no current is flowing. So no armature flux is produced. Now let's see about the figure number 2. Okay. So this is the discussion about the only figure number 1. When my armature at no load. Then let's see what will be happen. Suppose I am loading my armature. So here in figure number 2 shows the effect when purely resistive load. That's why my power factor is unity. Is connected across the terminal of the alternator. So now I am loading my armature with the resistive load only. So as I already told you, according to the right hand rule, the current is in. So here that's why I am using the comma. There are two in. Okay, this in for the inside direction. So according to the right hand rule, the current is in the conductor under N pole. So those conductors are under N pole. In that, current is inside in direction, and those conductors are towards the S pole direction. The current is outward direction according to thumb hand rule. Sorry, not thumb hand, right hand rule. So the current is in the conductor under N pole and out in the conductor under S pole. Okay, according to the Fleming's right hand rule. Okay. So therefore the armature flux is clockwise due to the current in the top conductor. So you can see here this flux. Here my current, direction of current is inside. Okay, so suppose I am putting the inside, this is the left side inside direction, and my conductor is now moving this one. So as my conductor moving, my flux will be changed. So that's why this flux is in clockwise direction. You can see here I am showing you the direction. So those conductors who are under N pole, or those conductors in which the current is going into the plane or into the plane, then my flux is clockwise direction. And here, for those conductors whose current is outward direction, that flux is in the anti-clockwise direction in nature. Anti-clockwise direction in nature. So you can see here for upper conductor, the direction of the flux is in clockwise direction, and for lower conductor, the direction of flux is in the anti-clockwise direction. So you can see the armature flux is clockwise due to the current in the top conductors and anti-clockwise due to the current in the bottom conductors. Okay. So note that the armature flux is at 90 degree to the main flux. Here you can see this is the only main flux. This one and this one. And these fluxes are 90 degree to the main flux. Are 90 degree to the main flux. From the both the figure you can easily understand. These flux are due to the only main flux, and these flux are due to the current which is flowing to the armature. So if you are see, it will be at 90 degree. Okay, electrical. So due to rotor current, and it is behind the main flux. It is behind the main flux. So let's say this is past my main flux, then afterwards this one, so it is behind. So it is behind the main flux. So in this case, the flux in the air gap is distorted. Okay, so when your load is purely resistive in nature, so your armature flux is distort your main flux, but it will be not add or not oppose. So it will not weak your main flux, or it is not strengthen your main flux, but it simply distort your main flux. Okay, it simply distort, not strengthen, not weaken. So when your load is only resistive, then the flux in the air gap is distorted, but it is not weakened. Okay, so its magnitude, you can say its value remains same. It will be not increase, not decrease, but its shape will be changed. Its shape will be changed. Suppose, let me show you. Like that. This is the armature flux and this is the main flux. We are at this. The value remains same generally, but the shape will be distorted. So therefore, at unity power factor, the effect of the armature reaction is merely to distort the main field. Okay, the question like that also, what will be happen to the main flux when our load is purely resistive? So there, simply your answer will be, it will distort the main flux. Okay, in 1 mark question, any question will be asked. Okay, what is the effect of armature flux on the main flux when my load is purely resistive in nature? So only one sentence, your answer will be in only one sentence. It will distort the main flux, simply. Okay, so when my load is resistive, it will only distort the main flux. It will not weaken or it will be not strengthen. Okay, so there is no weakening of the main field, and the average flux practically remains same. As I already told you, its magnitude remains same. Just its shape will be changed. So since the magnetic flux due to the stator current, means armature flux, rotates synchronously with the rotor, the flux distortion remains the same for all position of the rotor. Here I am talking only in this condition when my rotor is in the say at the R1 and R2. Now it will be rotate. It's suppose B1, B2. Then it will be on the same again same distortion. Again it will be at the Y1 and Y2. It will be same. Again let's say my N pole is in front of R2 and my S pole is in front of R1. Again it will be same. Why? Because my magnetic field or magnetic flux is also rotated at the synchronous speed, and my armature flux is also rotated at the synchronous speed. Okay, so that's why it is remain same. So the last statement is very much important. Is the magnetic flux due to the stator, means armature, and the magnetic flux due to the rotor, means field, is synchronously with the rotor, so the flux distortion is remain the same. The flux distortion is remain the same for all the position of the rotor, for all the position of the rotor. Okay. Now the next one is, let's say my power factor is 0 lagging. What that means? Suppose now my load is inductive in nature. Okay, so when it is lagging, we have to assume always inductive in nature, my power factor is lagging. And for leading, it will be capacitive. So you can see here, so when my pure inductive load, okay, you are aware about the pure inductive. Then pure inductive load, what will be happen? Either my voltage is 90-degree lagging or my current is 90-degree lagging to the voltage. When suppose I have a pure inductive nature, who is lagging? Voltage or current? Current. Okay, current is always for pure inductive load I am talking. For pure and inductive load, my current is always 90-degree lagging. Why is it so? But what will be happen when I have inductive load? What opposes the current? We are giving the supply. Okay. So when you have a resistive load, when you are giving the supply, at the same moment your current will be started. Okay. But when you are giving the supply to the inductive load, why after 90-degree your current will be started? Not by it. There is some force if you oppose the suppose in capacitor, what will be happen now? In capacitor, after that it is capacitor. So in capacitor, what we are talking? My current is 90-degree leading. Okay. For first of all, when current will start flowing, you are giving some supply then and then. Now you are giving the voltage to the capacitor first. Then also your capacitor voltage will be 90-degree after current. Why it is so? In inductive load, when we have a yes, there is one answer is there also. Yes, inductor oppose the change in current, but what? Why? Because in inductor there is one force which is created due to the term self-inductance. Okay, so there is some self-inductance, so there is some self-induced EMF. So that self-induced EMF oppose the main voltage. So due to that, current will be lagging by the voltage. Okay, due to the self-induced EMF. There are two types of EMF. One is the self-induced and another one is the mutually induced EMF on which our transformer are working and on which our generator induction motor is working. Okay, because flux is generated by the field winding, that field will be linked with the another conductor, and due to that linking on that conductor EMF is generated. So most of the time we are talking about the mutually induced EMF always, but there is one another EMF is also there which is known as the self-induced EMF, and it is only present when we have a inductive load. So here you can say when we have pure inductive load, zero power factor lagging, you can say, is connected across the terminal of the alternator. My current lags behind the voltage by 90-degree. So this means the current will be maximum at zero EMF and vice versa. Okay. Means vice versa means when we have a zero EMF, then my current is maximum. And when my EMF is maximum, my current is zero. Like that. So now let's see what will be happen in these two cases. Here we have two possibilities, either E max or I max. And in this figure number 2, we are talking about the I maximum only. Now what they are talking about, let's see about that. So figure 1 shows the condition when the alternator is supplying resistive load only. Okay. So note that EMF as well as current in phase R1 and R2 is maximum in this position. So here in case 1, what we are talking about when my load is only resistive. And in case number 2, we are talking about when my load is inductive. Okay. So here, okay, so first case we are not showing here, then my alternator is at no load. Now assume that my alternator is already on the load and that load is resistive in nature. So here my maximum voltage and maximum current. So when my voltage is maximum, at the same time my current is also maximum. Why? Because my load is resistive. But now I am adding the inductive load. Then what will be happen? So note that the EMF as well as current in the phase R1 and R2 is maximum in the position shown. Why? Because my position is same. My N is across the in front of R1 and my S in front of R2. So that's why the voltage and current is maximum in R1 and R2. But suppose if you are changing this rotor and it is, let's say it is in front of Y1 and Y2, then the voltage and current is maximum at Y1 and Y2. Okay. So now what we are doing, now the alternator is supplying pure inductive load. Okay, so we are adding the pure inductive load, removing the resistive load. Then what will be happen? So now my current in phase R1 and R2 will not reach its maximum value until my N pole advance 90-degree electrical. Okay. As you also told about that, my current is 90-degree lagging the voltage. My current is 90-degree lagging the voltage. So suppose at that point I required my current at maximum value. So my voltage must be, suppose again I am talking about that my current in inductive load, my current is 90-degree lagging. What that means? My voltage is 90-degree leading. Okay, we can say two ways. In inductive load, what we are talking always, my current is 90-degree lagging the voltage. But another, I can say in inductive load, my voltage is 90-degree leading than the current. Okay, both are same. So I want my current maximum at this point. So what I have to do, my voltage must be 90-degree leading. So when my voltage will be 90-degree leading, when my rotor position is at that position 90-degree to the R1, then and then my current will be maximum. Okay. So when my voltage at the 90-degree to the current, then here my current is maximum. Okay. If my voltage is 90-degree leading, then my current is maximum. So here screen not visible. So there is one question that my screen is not visible. It is visible to everyone, my screen. Those who are attending the session online, yes, sir. Okay, so Prem, I request you leave the meeting and rejoin again. Okay, there is some issue with your network. So now you can see here, when the alternator is supplying a pure inductive load, the current in phase R1 and R2 will not reach its maximum value until my N pole advance 90-degree electrical as shown in figure. So here in this figure, I'm advanced my voltages by 90-degree. Okay, 90-degree. So now the armature flux is from right to left. You can see here, my armature flux is right to left in both the cases. In first, when we have a resistive load, then my armature flux for the conductors who's under the N pole, it is in the clockwise direction, and those conductors who's under S pole, it having the anti-clockwise in direction. But here, my armature flux is in the same direction. You can say from right to left for the all the conductors. You can say. Okay. So now the armature flux is from right to left, and field flux, okay, is from left to right. You can see this is my field flux. It is in the left to right, and my armature flux in this condition is right to left. So both are opposed to each other. One is right to left, another one is left to right. So both are opposed to each other. So here, when your load is purely inductive in nature, your total flux is weak. Why? Because your armature flux is oppose your main flux. Your armature flux is oppose your main flux. So all the flux produced by armature current is oppose the field flux, and therefore it weakens the main flux. It weakens your main flux. In other words, Again, you are thinking about the two things. When we have a DC generator and armature reaction, then there are two possibilities: demagnetizing and another one is, there are two possibilities for the armature reaction for the DC generator: demagnetizing and you have to aware about that. You just learned in the fourth and they are already studied in the third. It's already 6 months, so they forgot all the things. Demagnetizing and cross magnetizing. Okay, so here when your flux is weakened, then it is known as the demagnetizing. So in other words, the armature reaction directly demagnetize. Okay, because it is already weak your flux. So hence at zero power factor lagging, the armature reaction weakens the main flux, and this causes a reduction on the generated EMF. As your flux is weak, due to flux only the EMF is generated. Okay, because if you are aware about the equation of EMF, it is EPH is equal to 4.44 TPH phi, then KP KD. That phi is the flux. So if your main flux is reduced, your voltage is also reduced. If your main flux is increased, your voltage is also increased. If your main flux is remain constant, your voltage remain constant. Okay, because your generated EMF is directly proportional to flux also. 4.44 is constant. Then 3 or 4 things we have to aware about that. TPH, total number of conductors. Once your armature or alternator is designed by the 1700 conductors, it remains constant all over the time. So your TPH is always also constant. KP and KD. So distribution factor depends upon the beta and M. M is the slot per pole per phase. Your phase is constant, 3. Per pole, your slot is constant. Once your alternator is designed with the 20 slots, it always remain the 20 slot. It will be not increase the slot. We cannot increase the slot from 20 to 30, or we cannot decrease the slot from 20 to 10. So again, your M constant, beta, slot angle. Your slot is fixed, then your slot angle also fixed. So your KP, KD, TPS, 4.44, all things are remain constant. So generally, the generated phase voltage is always depend on the flux phi. So your EPH is proportional to phi. So if your phi increase, your EPH increase, and here in inductive case your phi decrease, so your flux is also, your EMF is also decrease. So you can see this causes a reduction in the generated EMF. So another one case which is about the when we have a power factor 0 leading, and finally we are taking the summary. What will be happen when my load inductive lagging leading and any randomly lagging 0.7, that we will see in the next class. Okay, so up to this, if anyone having any doubt, you can ask me a question. So those who are attending the session online, if anyone having any doubt. Okay, so those who are attending the session online, I request all of you, please write down your enrollment number in a chat session for the attendance. Okay, and once you write down that number, if you want to leave, you can leave the session and join the another session of the power system too. ધીરે ધીરે ભાઈ.